Hello and welcome to this tutorial video. In this one we will build a small 3D level with Three.js with a movable AI character. We can let the AI character move via a mouse click and the character will find a way on its own to the target location. So first of all, a brief explanation of the navigation mesh. A navigation mesh, or short Navmesh, is a mesh which is invisible in the 3D scene and is used by a pathfinding algorithm to find a way from a start point to a target point. In this video we will use the library three-pathfinding, which implements a pathfinding algorithm. It requires a nav mesh which we will create with the tool called UPBGE. This tool is a standalone game engine extension for Blender. When you open it, you see that it looks exactly like Blender, but there are also some game engine features, for example, a tool to generate a nav mesh on 3D objects. Now I would like to discuss the setup of the 3D scene. I assume you already know how to create a Three.js scene, so I briefly go over it. As you can see, I have added only the basic things, like a camera with orbit controls. I added some light sources and added a green cylinder, which will be my movable AI character. I have put the cylinder in a group, so instead of moving the cylinder, I will move the group, while the cylinder will have a height offset within the group. And also I have added the three-pathfinding dependency. I will use it later. Okay, now it's time to build the 3D level. So I have just opened the Blender game extension. And I'm going to build a basic level with slopes, steps and with a bridge. At first I'm going to scale the starting cube on the X and Y axis by 10. This will be the ground. Now I'm going to switch to the edit mode and use the face selection mode. I select the top face and subdivide it 4 times. The reason why I do this is because I want to select faces on the surface and extrude them to create walls. And to make it easier for me, I turn on the incremental snapping. Now I just go ahead and select the areas where I want to have the walls. And then just simply extrude them on the Z-axis to raise the walls. Now I want to create slopes on the sides so the character can run on top of the walls. For that I switch to the vertex selection mode. And then I select the vertices where I want to have the slope. I am going to grab them along the Z-axis and rotate them to create the slope. And also I do that on the other side as well. Also, I want to have some stairs. For that, I just select some faces and extrude them. Okay, now comes a tricky part. I want to have a bridge from one side to the other side. And for that, I will subdivide the faces here. Then I'm going to extrude them and connect them on the other side. In order for the connect to happen properly, I switch the snapping mode to vertex. And then simply select the faces. And then extrude them. And as you can see, the connect happened perfectly. There is one thing to consider. Switch to the X-ray mode and select one of these vertices. So actually we have two vertices on top of each other. There is no connection between those vertices. And this raises the issue that we cannot have a path via this bridge here. And in order to fix that, we must merge the vertices. So go ahead and select all those vertices. And then press M for the merge menu and select by distance. And now instead of having vertices on top of each other, we have merged them. And now we have a connection via this bridge from one side to the other side. At last, let me change the color of the ground here to something else. Finally, we can generate the Navmesh for this level. First, go to the scene section on the right panel. And here you have a bunch of settings, and along them there is the navigation mesh section, so uncollapse it. So we have some settings here for the nav mesh, and most importantly are the agent settings. I have a cylinder with the height of 1 and the radius is 0.25, and the max climbing height, which is important for the steps here, is something like this. And now let's press the Build Navigation Mesh button and check it out. And there you go, we have a new mesh here in the object tree, and this white mesh here is our navigation mesh. And I briefly check if all areas are connected via the nav mesh. And if this is not the case for you, then you must tweak around with the settings here, or maybe there is no connection, like for the bridge here, for example. And for me it looks good, and it's time to export the level and the nav mesh. So at first I export the level mesh, so I select this cube here, which is the level mesh for me, and go here to File and Export, and I export it as a GLB file, and then select the order where I want to export it. This is in the dist folder, in the GLB folder. And I say it's demo level GLB, and also important, uncollapse the include section and check selected objects only. So I will export only the selected object here, and then click on export. And then I do the same for the nav mesh, select the nav mesh and export as GLB file. And I name it different, and this is the nav mesh. Also, don't forget to have this checked, selected objects only. Alright, and back in my development environment, I check if the files are existing here. I have the demo level and the demo level nav mesh, and everything looks fine. Now I need to load these meshes into my Three.js scene. Alright, it's time to load the GLB files. For that I will create a new instance of the GLTF loader. It is a new GLTF loader. And then I say loader.load, and I provide the path to the demo level GLB. And then I get an instance of an GLTF object. And then what I'm gonna do is I access the scene of the GLTF object, and I add it to my own scene. And then save it. And then I immediately see the result. And yeah, so this is the level which I have just built in Blender. And my agent is right there where he needs to be. And that is looking good. And to load the nav mesh, I also use the GLTF loader. I say loader.load, and I provide the path to the Navmesh GLB file. And again, I get a GLTF object. So what I'm gonna do is I temporarily add the Navmesh to the scene, just to display it. And there you go. So this is my Navmesh. Just briefly take a look at it. And as I said, I actually don't want to display the Navmesh in my scene, but instead I'm gonna provide it to the pathfinding library. So let me prepare the imports for the pathfinding library. The pathfinding object is that one which will take care of the pathfinding and where I will feed my Navmesh. And the pathfinding helper is a helper class which displays the nodes and lines of the path in the 3D scene. So at first I create an instance of the pathfinding object. Then I'm gonna create an instance of the pathfinding helper class. And I'm gonna add the pathfinding helper to the scene. The pathfinding library creates a zone out of a Navmesh, and it can handle multiple zones. I need to define a zone ID for my level. And then I'm gonna define a couple of variables. One variable is for the Navmesh itself. One variable for the group ID, which will be provided by the library later. And one variable for the navigation path. So once the GLTF object of the Navmesh file has been loaded, I need to find the mesh within the GLTF scene. So I'm gonna traverse the nodes within the GLTF scene. And then I'm gonna check if I have not found a Navmesh yet, and if the node is a 3D object, and if the node has children. So the first children which I found is actually the Navmesh. And then I provide the Navmesh to the pathfinding object. So I say pathfinding set zone data, and I provide the zone ID, and I use the pathfinding object to create the zone out of the Navmesh. And I use the geometry of the Navmesh. So with that, we have successfully loaded the Navmesh and created zone data for the pathfinding library. And what I want to do now is I want to create a path from the position of the agent to a position which I specify via a mouse click. For that, we're gonna use the Three.js Raycaster. The Raycaster enables us to cast a ray from the mouse position into the 3D scene and to calculate and to detect intersections with a 3D object. So let's go ahead and create more variables. And at first I need to have a Raycaster. And then I need to have the mouse click position, a two-dimensional vector. And I'm gonna add a click event listener. So I say window add event listener. The event is a click event. And then I am creating a event handler. The event contains the X and Y position of the mouse click event. We need to transform these X and Y positions into the normalized -1, +1 2D dimensional positions. And for that I'm gonna use this here. So I access the client X position, divide by inner width times 2 minus 1, and on the Y position divided by inner height times 2 plus 1 and negate it. And this will create a normalized position. And having that normalized mouse click position, I can access the Raycaster. So I say Raycaster set from camera, and I provide the click mouse position, the normalized position, and my camera. And then I'm gonna say Raycaster dot intersect objects. And I need to provide the children of my scene. And I assign the result into a variable, and I name it found. And the found variable is an array which will contain the intersection points within the 3D scene. So again, what happens here is if I click here, then array is casted into the 3D scene, and all intersection points are gathered in that found array. And then I can check if the found array contains any findings. If that is the case, then I get the first intersection point. And this is the target of my path. Now I have the position of the agent and the target position of the path, and I can start using the pathfinding library. And at first I must get the group ID of the closest node to the agent position. So I say group ID is equals pathfinding get group, and I provide the zone ID and the agent position. So having that, what I also want to do is I want to get the closest node position within the Navmesh towards the agent position. It sometimes happens when the agent is moving that it moves out of the Navmesh, and then the pathfinding given the agent position does not work anymore. So I say const closest equals pathfinding get closest node, and I provide the agent position again and the zone and the group ID. So now I have the position of the closest node to the agent position, and I can finally start the pathfinding, and I say nav path. This is the found path, and it equals to pathfinding find path. And I use the closest node position and the target position, the zone, and the group ID. The navPath variable should contain an array of positions along the path. So what I want is I want to visualize that with the pathfinding helper. At first I check if I have found a path, and then I use the pathfinding helper and say reset, just in case I have found something before. And then I say pathfinding helper set player position, and this is my agent position. And then pathfinding helper set target position, and then pathfinding helper set path, And this is the navpath variable. And now we can test it and click on the level, and we see that we have now a path. And I click anywhere where the agent could work, and I see that the pathfinding is working. Alright, we're almost done. The only thing what is left is moving the agent along the path. So we have the path points, we move the agent from one point to another until he reaches the target. And we're gonna animate the agent in the game loop, and at first we create another function for it. And the function is something like this, move, and an input variable named delta of type number. This is the delta time, which is has passed from frame to frame. And at first I check if I have found a path. If this is not the case, then I will simply return from the function. So at first I need to get the first entry of the navpath variable. Navpath. The first entry in the navpath array, it would be that point here. And after I have reached the point, I will remove it from the array, and then I will move to the next point. And then we're gonna calculate the distance from the agent towards that point. I am introducing a new variable. And target position dot clone. And subtract. And I will subtract the agent position. And then I need to check if the distance towards the target is above a certain threshold. And yeah, distance, length, square. If it is above something like this. And in the other case, that means I have reached the point, so that means I am going to shift the navpath array. And that will simply remove the first entry, and in the next iteration of this function I will be at the next point on the path. If I still did not reach the target position, then I'm gonna normalize the distance vector. And then I'm gonna use that distance vector to calculate a movement offset vector to move the agent. So I say agent group position, and then I add another vector onto it. And this will be the distance vector multiplied by a scalar. And I use the delta time for it, and then some hard-coded speed constant, something like this. So again, to summarize that, at first I get the first node on the path, and then I calculate the distance from that node to the agent. And if the distance is large enough, that means I need to move the agent towards that node. And then I calculate some offset vector given the delta time and some speed constant, and move the agent towards that node. And if I have already reached that node, then I simply shift the path array, and in the next iteration I will get the next node. So now I need to use that move function in the game loop. So I put it right here, move, and I use the Three.js clock to calculate the delta time. And now I can test it. I simply click here and you see that the agent is moving along the path. And it works anywhere where I click. So that's looking good.